Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on sequences and series for mathematics grade 12. And this is part 1 of a 4-part series. And this is a deep dive on the arithmetic series. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 2 all the way to part 4 on this series. We have a lot to cover, so let's start. Now, in general, we're going to cover number 1, the definition of a arithmetic sequence, and then the general term, that is number 2. Number 3, we're going to look at the sum of the first n terms, and number 4, we're going to look at an introduction to sigma notation, because that's important and you'll see why it's important. We'll just only cover the introduction. The deep detail on sigma notation is going to be done in a future video in this series. Number 5, we're going to look at an example from past exam papers. We have a lot to cover, so let's start. Let's look at the definition of an arithmetic sequence. An arithmetic sequence, or linear sequence as it is sometimes referred to, is an ordered set of numbers called terms in which each new term is calculated by adding a constant value to the previous term, and that constant value is what we call the constant difference. Now here is the general term of an arithmetic sequence. Here is the general term is Tn equals to a plus in bracket n minus 1 all times d, where Tn is the nth term and n is the position of the term in the sequence. And remember, the number of sequence of terms in a sequence follow a pattern that is a natural number. They're all natural numbers. What are natural numbers? Please refer to a video I did on the number system so you understand who's who in the number zoo. Natural numbers are basically numbers you can use to count, and those start from 1 all the way to infinity, but they are whole numbers. They don't include fractions, they don't include negative numbers, and so on and so on. They are numbers of things you can count and see. If a baby can count it, that's a natural number. A, where A is the first term and D is the common or constant difference. It doesn't matter how you prefer referring to it, but it means exactly the same thing. Now let's look at some examples of linear sequences or linear patterns, if you can call them that. Now here are some examples. Now here is how you figure out whether it is a linear pattern or not, or an arithmetic sequence or not. You find the difference between the consecutive terms. Now t2 minus t1, in this case it's 6 minus 2. 6 minus 2, that gives us 4. And then the next one we go 10 minus 6, that also gives us 4. 14 minus 10, that also gives us 4. Now you can see the difference is constant and that difference is 4. So that makes this a linear pattern or a linear sequence or an arithmetic sequence. That's how you test whether a sequence is a linear arithmetic sequence or not. And you can pause this video and check the constant difference of the rest of the terms, and you will see that they all follow a linear pattern, and therefore making them the arithmetic sequences. Now let's look at the general term. Let's look at a worked example to demonstrate what the general term is in detail. Now remember, the formula for the general term has got this formula: a plus in bracket n minus 1 times d, where a is your first term and d is the constant difference. Now given the sequence negative 15, negative 11, negative 7, and so on and so forth, all the way to 173, this is a finite series, and we'll talk and look at finite and infinite series in a later video. Please keep that in mind. This is a finite series because it has a beginning and has an end, making it a finite series because it has a beginning and an end. One that has a beginning and no end, or an end but no beginning, is called an infinite series. Number 1 says, is this an arithmetic sequence? Let's check it out. How do we test for an arithmetic sequence? We find the difference between any two consecutive terms, consecutive meaning one after the other, so that will be term 2 minus term 1, that is negative 11. Take a calculator. Negative 11 minus negative 15, that gives us 4. That is the answer there. Now let's find T3 minus T2, that is negative 7 minus negative 11. That gives us also 4, and therefore this makes it a linear pattern or a linear series or an arithmetic series. So therefore the answer is yes. This is an arithmetic series. Please always answer the question because that's where the marks are hidden. This is an arithmetic series or a linear sequence. This is a linear arithmetic or linear sequence. You can choose which one you want to use. Any of the names is perfectly fine. Number 2, find the formula of the general term. Okay, let's do number 2. The general term has got the formula, remember? A plus in bracket n minus 1 times d. Now we know the constant difference for this one is 4, and the first term is negative 15. There is the first term. So let's go where a equals to negative 15 and the constant difference d equals to 4. Now let's substitute this into the equation and figure out, calculate to find what the general term is. So that will be negative 15 plus in bracket n minus 1 times 4. Expand that. Let's expand this. Now when we expand this, becomes negative 15 plus 4 times n minus 1 times 4. So that's 4n minus 19. Therefore, the general term is 4n minus 19, because negative 15 minus 4 gives us negative 19. That is the general term. Now, number 3 says determine the number of terms in the sequence. How do you do that? It's easy. Number 3, you know that the last term, or what we can call Tn, is 175. This is the last term, or Tn. It's up to you how you would like to refer to it, whether you prefer it as the general term, the last term, or Tn, or L, it doesn't matter. Now, let's use that to figure out what the number of terms we have. How many terms we have? That is the number n. We know that the last term, Tn, in this case is 173. And we also know that the formula for the general term is 4n minus 19. So we substitute that into this equation. That is equals to 173. Now we solve for n. Take the 19 to the right hand side, and that gives you 173 plus 19. Always use a calculator to make sure that you avoid making those silly mistakes which will end up with a wrong answer. That will basically ruin everything, because your next questions will depend on that wrong answer, making every other question you answer after that incorrect. Now, therefore, divide both sides by 4. So 4n over 4 equals to 192 over 4. Therefore, n equals to 192 divided by 4. That gives us 48. Now, always answer the question, meaning that therefore there are 48 terms in the sequence. Therefore, there are 48 terms in the sequence. And that's how you answer the question. Now let's look at the sum of the first n terms. The sum of the first n terms, I'm going to forego all that process of proving it. You can do that. There's information in your textbook. Please go through it. You can go through all of that. Now, the general formula for determining the sum of the arithmetic series is given by, there you've got two options. The first one is Sn equals to n over 2 in bracket 2a plus in bracket n minus 1 times d, and then close bracket. This is almost identical to the general term. Remember, instead of a, just a plus this, it's 2a, and then you've got n over 2 in front of it. Just something to help you remember. And the second one is Sn equals to n over 2 in bracket a plus l, where l is the last term. L equals to the last term of the series. Now this is when you are dealing with a finite series which has the last term given to you and is known. You can just use this to find the sum of the first term. I personally prefer this one because whether you know what the last term or not, you can use it and you'll still be good every time. So now let's look at the introduction to sigma notation. Now the reason why I'm going to do this is because we're going to look at questions from a past paper that also include some questions on the sigma notation. Now the sum of the first n terms can also be written as the sigma notation. This is the sigma notation sign. It means sum of I equals 1 to n of ai. Meaning what? Meaning that I is a number that changes based on the position of the term. It starts all the way from 1 all the way to n. So it goes a1, that's the first one, plus the second one is 2, so that would be a2, plus a3, plus a4, all the way to plus an. That's what the sigma notation, this side, stands for. That's what it means. That's basically all there is to it. Now, let's use this knowledge to apply to the example that we're going to take a look at now from a past exam paper. Now, an example from past exam papers. This one comes from paper 1 of the Department of Education, November 2021 year, national certificate, the national senior certificate, the Department of Education. Now consider the linear pattern 579 ... meaning that it continues. It's an infinite. It's an infinite. It's not finite. It's an infinite series. 4.1. Determine the 51st term. Term 51. We are told this is a linear pattern, so we don't have to guess. However, if you wanna check for yourself, you can just check if it really truly indeed is a linear pattern by finding the difference between any two consecutive terms. 7 minus 5, that gives us 2, and 9 minus 7, that gives us 2 also. Yes, therefore it is a linear pattern. We've proven that. Now let's find the 51st term. Remember, a linear pattern has got the general term with a specific formula. Here is the formula for the general term, a plus in bracket n minus 1 times d. We're looking for T51, right? We know that a equals to, okay, T51 is what we're looking for, so we go T51. We put a question mark on that. Keep our brain always focus on the fact that that's what we want to find as a question. Now, where a, the first term, is equals to, let's go back, where the first term is equals to 5 and the constant difference is equals to 2. Where the first term equals to 5 and the constant difference is equals to 2. Now let's use this information to substitute back into the general equation. Therefore, T51 equals to a is 5 plus n is 51. So that is 51 minus 1 times d is 2. Take out a calculator. Let's calculate that. So that will be 5 plus open bracket 51 minus 1 close bracket open bracket to close bracket equals 2, and that gives us 105. If you're using a Casio, that's how you should calculate that. And that is term 51 is 105. Now let's look at number 4.2. Next question, 4.2 goes, calculate the sum of the first 51 terms. We calculated the term, the 51st term. Now we're looking for the sum of the 51 terms. Well, remember the formula for the sum of the first n terms equals to n over 2 in bracket 2a plus in bracket n minus 1 times the close square bracket. Or we could use the other one. Or we could use the other one. N over 2 in bracket a plus l. Why? Because we've got the last term, which happens to be the 51st term given to us. So let's start with the first one, the second one. Okay, we could use this one as 51 equals to 51 over 2 in bracket. The first term is what? The first term is 5. And the last term is T51, which is 105. 5 plus 105. And that gives us an answer of, let's go, take out a calculator. That is common fraction button 51, downward arrow to right arrow, open bracket, 5 plus 105, close bracket, equals to, and that gives us an answer of 2,805. 2,805. Sorry, yes, 2,805. 2,805. That's method 1. This is method 1. Method 1. Let's look at method 2 using the other formula. Okay, if you use method 2, or we could say as 51 equals to 51 over 2 in bracket 2 times a is 5. That's the first term. Plus n is 51 plus 51 minus 1 times d is 2. That is the constant difference. D is 2. Then put a square bracket. Now take out your calculator. We go common fraction button. 51 at the top, downward arrow to right arrow. Open bracket 2, another open bracket, 5 close bracket, plus open bracket 51 minus 1 close bracket, open bracket 2, another close bracket, and then another close bracket for this one, and that gives us 2,805. It does not matter which method you use, because you know what the last term is. You can use either formula to give you exactly the same answer. So you choose which one works for you. I prefer the first one. If you prefer the last one, that's fine. Whichever you prefer, as long as you get the answer right. There are many ways to kill a cat. Choose whichever way works for you and stick to it. Now 4.3, write down the expansion of 5,000. Okay, the sum of, in bracket, 2n plus 3, excuse me, from n equals to 1 all the way to 5,000. Show only the first 3 times and the last term of the expansion. We're just showing the expansion. So we need to figure out what term number 1 is, term number 2, term number 3, and then the last term. All right, now let's do that. Now, first of all, let's find out what is the last term. The last term is term number 5,000. That is the last term. And the first term is term number 1. All right, so the last term will be term number 5,000 of this formula. So now let's go term 1. Okay, here is the general term, which is inside. The general term, which is Tn inside that sigma notation sign. That's 2n plus 3. That's the general term. So T1 is equals to 2 times 1 plus 3, which gives us 2 plus 3, which is 5. Just to make sure you are sure of what you're working with. Now, term number 2 will be 2 times 2 plus 3, which is 4 plus 3, and that gives us 7. The last one, term number 3, well, term number 3 is 2 times 3 plus 3 equals 2. That gives us 6 plus 3, which is 9. So these are the first 3 terms. Now the last term, which is term number 5,000. Let's calculate term number 5,000. All the way to term 5,000. That will be 2 times 5,000 plus 3. and that gives us 10,000 plus 3, which is 10,003. So therefore, when we write that sigma notation in expanded form, that will become I equals to 1 to 5,000. Or is it n equals to 1? Let's go back. From n equals to 1, yes, n equals to 1 to 5,000. Okay, let's fix that. N equals to 1 to 5,000 of 2n plus 3, meaning the whole thing is included in the calculation. Everything is counted for. All right. And that will be equals to term 1. Term number 1 is 5, so that will be 579. 5, 7, 9, then dot dot, then the last one will be 10,003. 10,003. Sorry, I missed a 0 over there. And that's how you write this in expanded 4. Now 4.4, hence or otherwise calculate the sum of 2n plus 3 from n equals 1 all the way to 5,000 plus the sum of minus 2n minus 1 all the way from 1 to 4,099. Now in order to calculate this, let's find the sum of this one. This is the sum of the first 5,000 terms for this one, and this is the sum of the 4,999 terms for this one. So let's go. Number 4.4. We're supposed to calculate from n equals to 1 to 5,000 of 2n plus 3 plus from n equals to 1 to 4,999 of minus 2n minus 1. Let's just double check that. That is correct. All right, let's go. So step number 1, let's calculate this. Let's calculate this. From n equals to 1 to 5,000 of 2n plus 3 is the same as the sum of the 5,000, which is equal to 5,000 n over 2, right? Remember the general equation of the sum of the first n terms in bracket, which is 2. And the first term here is 5. Remember 2 times 1 plus 3, that is 5, plus 5,000 minus 1 times, and the constant difference is 2. Remember T1 is 2 times 2 plus 3, that is 5. T2 is 2 times 2, which is 4 plus 3, which is 7. So D, the constant difference, is equals to 2. So the constant difference equals to 2, and we substitute it there. Now let's calculate this. Let's go. So that is common fraction button 5,000, downward arrow 2, right arrow open bracket 2, open bracket 5, close bracket, plus open bracket 5,000 minus 1, close bracket, open bracket 2, close bracket, and then another close bracket. Very important. All of that is equals to, it gives us, this is the number it gives us. I'm going to write it from the right hand side So it's 0 0 0 0 2 0 and then 2 5. So that is 25 million and 20,000. 25 million and 20,000. Now let's calculate the second one. Now this one goes sigma notation, 4,999 from n equals to 1, and that is minus 2 n minus 1. That is equals to the sum of the first 4,999 term. Now let's find what the a is, which is the first term. A is simply minus 2 times 1 minus 1, which is minus 2 minus 1, which is negative 3. Then the constant difference, okay, let's find T2 first so we can find the constant. That's minus 2 times 2 minus 1, which is negative 4 minus 1, which is equals to negative 5. Now therefore the constant difference will be term 2 minus term 1, which is equals to negative 5 minus negative 3, and that gives us minus 5 plus 3, which is equals to negative 2. That is D. That is the constant difference. Therefore, the sum of the first 499 term, 4,999, therefore, that is equals to 4,999 over 2 in bracket 2 times the first term, which is negative 3, plus 4,999 minus 1 times the constant difference is negative 2. And now that gives us, you take out a calculator, let's go, common fraction button, 4,999, downward arrow 2, right arrow, open bracket 2, open bracket, negative 3, close bracket, plus 4, open bracket, 4,999 minus 1, close bracket, open bracket, negative 2, close bracket, another close bracket to seal it off, equals to, and that gives us negative, it's a negative number. I'm going to write it from the right hand side. So we've got 91999, 3 nines, another set of 3 nines, and then we've got 24. So that is negative 24,999,999. So therefore, this sigma notation plus this sigma notation gives us this. So the one we calculated, that is 25 million and 20,000. So that will be 25 million and 20,000. 25 million and 20,000 minus, okay, plus, you can just go plus, and then that is negative, plus negative 24 million 999,999. Take out a calculator. Let's calculate this. So it's 25 million and 20,000 minus or plus negative 24 million 999 and 999, and that gives us 20,001, and that's the answer to your question, 20,001, and that's the final answer. We'll come to the end of this video. Thank you so much for watching. I'll see you in the next one. Please don't miss the next dives we're going to do on the other sequences in series. See you in the next video. Bye bye.